Hello students, this is Mr. Damiani, and today we are going to look at video lesson 7.9. This is located on page 407 in your practice book. We're going to begin on page 407, but then we're going to jump right ahead to the share and show on page 409. So I want to review a couple things before we get to that point. The topic for today's lesson, building off of 7.8, is we are going to identify equivalent expressions. 7.8, we generated equivalent expressions, so now we're just going to be given a pair of expressions, and we're going to have to decide, are they equivalent or are they not? So the essential question, how can you identify equivalent algebraic expressions? All right, so we do have some different options. The first thing I would like to do, though, is we're going to look at the steps that we use to identify equivalent expressions. The first thing that we can do is utilize the distributive property. So you want to think back to what the distributive property was. Step one, we are going to use the distributive property. Always check for distributive property, and remember, if there are parentheses, odds are we can distribute. Step two, or the second checkpoint. So if you can apply the distributive property, perfect. If you can't, we always check to see if we can combine like terms, terms that have the same variable part. So we're going to look for the application of CLT. And then the third item here is we can always factor. All right, when do we look to factor? Well, the general rule is this. If you cannot apply distributive property and you cannot combine like terms, then we would look to factor using the latter method. Okay? So these are the three pieces that we are going to use in order to identify equivalent expressions. So I would like you to go ahead now and turn to page 409. All right, so I'm looking at page 409 here, and I'm going to work on the first question here over to the right. I don't like the work that they may have suggested using that commutative property of addition. We're going to go about it the way we've practiced in class yesterday. So I'm going to start by looking at the expressions. I have 7k plus 4 plus 2k, and I also have 4 plus 9k. Okay, so these are my expressions. I do a little T-chart, help me get that organized, and if you look at the 7k plus 4k plus 2k, it looks a little more complex than the 4 plus 9k, so I'm going to operate with the expression that looks like it's not simplified, which is the 7k plus 4 plus 2k. So I'm going to take that and I'm going to use that commutative property by rewriting the order. So I'm going to write this as 7k plus 2k plus 4. And I'm going to underline my like terms. And I'm going to apply combining like terms here because I do not see any parentheses. So I'm going to go ahead and do 7k plus 2k, which will give me my 9k, plus the 4. I'm going to stop there because I cannot simplify that any further. And over here I have 4 plus 9k. So the commutative property of addition tells me that the order in which I add does not matter. So these expressions are equivalent. 9k plus 4 is the same as 4 plus 9k. So down here on the line I'm going to go ahead and write equivalent. All right, and essentially that's what we're going to do for the problems that we're facing today. So we're not going to really learn anything new. We are just going to simplify expressions to try to get equivalent expressions. So let's go ahead and slide down, take a look at question 2 here. We are given two terms. We are given 9a times 3 plus 12a. Okay, so I have 9a times 3, and I have 12a. So I look at the 12a here, and that already looks simplified. So I'm going to do work with the 9a times 3. Now, the nice thing with multiplication is we can multiply our coefficients. So 9a times 3, 9 times 3 is 27. So the simplified version of this is 27a. So I have 27a and 12a. These expressions are not equivalent. So you would write in there, not equivalent. And you can abbreviate that too, that's not a problem. Okay, let's get into question 3 here, and then I'm going to let you try a couple on your own here. So question 3, I have 8p plus 0, and I have 8p times 0. Well, if you look at 8p plus 0, I could simplify, sorry, I can't simplify that any further. It's already simplified down. However, 8p times 0, doesn't matter what 8 and p are. Anything multiplied by 0 is 0. So these are not equivalent because 0 and 8p plus 0 are not equivalent at all. So let's move our attention to question 4. This is going to be probably the most complex one that we've had up until this point. So let's work together on it here. So I have 5 times a plus b, and then I have 5a plus 2b plus 3b. Okay, so and I've got some parentheses around there. So what we want to do is we want to go ahead and apply one of the properties, and I'm going to notice here that I'm going to want to apply the distributive property here. So we're going to go ahead and distribute that the 5 by saying that is 5 times a, so that's 5a, and I'm going to distribute it to the b, and that's going to be 5 times b, and that's going to be addition in the middle. So I have 5a plus 5b. Well, when you look at this, you say, okay, well that looks very different than the 5a plus 2b plus 3b. But if you remember our associative property, we can group our addition any way we want. And I could actually go in there and combine these two like terms. So I can copy down that 5a plus 2b plus 3b is 5b. So 5a plus 5b are actually, these are two actual equivalent expressions. All right. Okay, so you've seen we're just simply working expressions down, trying to see if we can get them to be equivalent to each other. What I would like you to do now is I want you to go ahead and pause the video for me, and I would actually like you to complete for me question 7 on your own. So go ahead, pause it, complete question 7 on your own. Thank you. All right, thanks for pausing the video here. And I'm hoping that I would have seen a t-chart here, and I would have seen two expressions written. And I'm hoping you would have simplified this one down and said, okay, 4 times 7 is 28. The b travels because of the multiplication, and 28b equals 28b, so we have equivalent expressions. All right. What I would like you to do now is go ahead and pause the video, and I'd like you to do some work on question 5. All right, I started with 7 because that was just a little bit easier. So I'd like you to pause the video, complete question 5, and then we'll go over it. Okay, thank you for taking the time to pause the video. Definitely going to start with a t-chart here. And I have 16v here, so I don't have to do much work with that. But I do have 3 times v plus 2 here, plus 7v. So I do have to do some simplifying here. So we go through our little checklist. First thing I always check for, distributive property. Can I distribute? And the answer there is yes, I can actually distribute 3 times v, which is 3v, plus 3 times 2, which is 6 plus 7v. All right, so I look at that, I say, it's still a little bit of a busy expression. So what I want to do now is I would like to see if I can combine like terms. And you look at the expression, you notice you have a 3v plus a 7v. That is 10 v's here plus 6. I cannot combine 10v plus 6 because these are unlike terms. So this is my simplified expression here. And 16v is already simplified. So 10v plus 6 is not equivalent to 16v. All right. What I would like you to do now is I want everybody on your own for your independent work. I'd like you to answer question 6 and 8 for us. And obviously 8's a go deeper question here, so that's going to be a little bit more challenging. Remember, please, if you have any questions, get them on a post-it note. And also for my class, we want a key idea on a post-it note as well from the video lesson. So any type of reminder that helps you be successful with lesson 7.9. Have this stuff all set for class tomorrow. Get in to school, ready to work, and we'll start wrapping up chapter 7. So thanks for taking the time to watch the video. Your hard work is always appreciated. And make sure you give a nice shout out to Mrs. Dubé. She's a fantastic teacher, so give her some high fives in the morning as well. Take care. Have a great night. Goodbye.